Okay, so this video we're looking at momentum and then change in momentum. So momentum as a concept can be just a little bit tricky, but if we consider a tennis ball and if we consider, I don't really know how to draw it, but here's a train. You'll have to fill in the details. It's the old sort of smokestack and smoke coming through for a steam engine and whatever, the grill on the front. Okay, train, big, heavy, got wheels, lots of wheels. Okay. So the ball has a much lower mass compared to the mass, which is much larger, of the train. But you can hit a ball pretty fast. Say if it's a golf ball, you can get to, well, I don't know actually, but definitely a lot faster than the train. You can hit a golf ball faster than a train, so the velocity is going to be higher than the velocity of the train. Now, in terms of momentum, you may have seen the formula P equals m times v. Momentum links these two aspects, mass and velocity, to deal with the propensity for an object to maintain its motion. So let's just make a little note about that. It's about, momentum is about maintaining motion. So an object with a higher momentum will maintain its motion better than an object with lower momentum. And you'll notice I've allocated the lower momentum to the golf ball, or to whatever the ball is. Even though the mass of the ball is very, very low, the velocity is very high. The mass of the train is much, much higher in comparison than the velocity is lower. So another way to look at it is momentum is directly proportional to mass and directly proportional to velocity. For two objects that are the same mass, whichever has the higher velocity will have the higher overall momentum, and therefore will be harder to arrest its motion, harder to stop. And that goes back to Newton's second law and impulse, which is a later little video further down the track, so I won't get into that now. But you basically have to apply a force for a longer period of time to change the momentum. So that's just a little heads up for that. Now, generally speaking, change in momentum is change in any quantity is going to be final minus the initial equals the change in momentum. So the temptation is just to do this very common sense, because a lot of the examples you'll get will be one dimension. We start off going in a particular direction with a particular amount, and then you change and you have a final amount of momentum, and then you can see, well, it's decreased by this amount or whatever, and you just tell that as the value. But I want you to get into a habit, if I can do so, to using this formula, change in momentum equals the final minus the initial. When it comes, the reason why, I'll give you a little heads up, the reason why is when you come to doing vectors and vector changes with momentum, it's going to be so much easier if you just follow this routine. So you learn the routine, so use that for change of momentum no matter what the situation, whether it's a vector or a more one-dimensional linear situation, which is also vectors anyway, but just go with me, and then enter that in the final minus the initial. I'll give you a very quick example just so that we've got something there for you to work with. If we have, we'll stick with our ball, and we'll make it a large ball, maybe a shot put, 1 kilogram of mass, and you throw it, and what have we got? Let's say it's going quite a high, 10 meters per second. You can imagine the damage that would do. It's quite nasty. But then say it hits a bird in the air, and then so there's a collision. I'm always unsure with collision. 2 L's, 2 S's, 1 L, 2 E, you work it out. Anyway, there's a collision with the bird in the air, and then it ends up at 5 meters per second. So really simply, our momentum, our change in momentum, if we're trying to find that, is the final minus the initial. The final in this case, remember momentum is mass times velocity. The final in this case is 5 times 1, and the initial is 10 times 1. put brackets around those just to make sure that they're clear and distinct. So we end up with 5 minus 10, and we end up with negative 5. And remember, the unit for momentum, mass is kilograms, velocity is meters per second. So kilogram meters per second is the unit for momentum, one of those a bit more clumsy ones. 5 kilogram meters per second. Now you might be thinking, why is it negative? And that just shows you that it's gone from this to this. It's a decrease in the same direction. So if you were to demonstrate the change of momentum, you would end up back this way. Okay, and that's a vector addition, final minus the initial, final plus the negative of the initial. Video's gone long enough, you get the gist. That is momentum and change of momentum, and we develop it a little bit further to impulse shortly.